Hey, it's your birthday? Happy birthday!
It's time for Maths with Mr. Thomas.
And on your birthday, we're going to be looking at Chapter 7, Trigonometry and Bearings, lesson number 9. It's another lesson looking at the cosine rule. In the last lesson, we used the cosine rule to work out the length of a side, but this time we're going to use it to work out the size of an angle. Woo! If we know all three sides in a triangle, we can use the cosine rule to work out the size of that angle. And the way we do that is we use the rearranged cosine rule, which is also given on the formula sheet, and that is cos A. So cos of our angle equals b squared plus c squared minus a squared divided by 2bc. Just remember, in the formula, the capital letters represent the angles, and the only angle we have, the only capital letter here is A. So for example, that there would be A because that's what we want to find. And A, B and C lowercase are going to be the sides. But what is very, very important is that if this here is angle A, then across from that, its pair, it's going to be lowercase a. And the other sides, the B and C, it does not matter which one is which. So as I said, A is the angle we want to find, small a is the side across from it, and B and C are the other two sides. So let's try some examples with that. Are you ready? I can't hear you. Are you ready? Yay! Let's do it. So example 1, calculate the size of the angle marked X in this bluish greyish triangle. So, to start off with, what is it we're wanting to find? We want the size of angle X. Good. So because this is what we're wanting to find, that there is going to be our A. So we can imagine that there is angle A. With this, if that is angle A, which side would be lowercase a? Is it the 14, the 20, or the 21? It's going to be the 20. Why, Callum? Why do you think it's going to be 20? Because it's across from it. Good, well done. So the side across from that is going to be lowercase a. Good. And the B and the C, it does not matter which one is which. So we've got cos A equals, but because we're calling this angle X, I'd probably go with cos X equals b squared plus c squared minus a squared. Well, remember, the b and the c, it doesn't matter which one is which. One of them is 21, one of them is 14, and we're taking away a squared. Remember, this side here, the 20 is a. So we've got the 14 squared and the 21 squared. We're adding them together, and we're taking away the 20 squared. And we're dividing that by 2bc, which is going to be 2 times by b times by c. And again, the b and the c are the 14 and the 21. So it's 2 times by 14 times 21. Or 2 times 21 times 14, doesn't matter the order, as long as the 20 only appears up here. And that's the one you're taking away because that's the one across from this angle that you want to find. To work this out in the calculator, a lot of the time I would work out the top row. So I would type that into the calculator. 14 squared add 21 squared, take away 20 squared. That gives 237. And if you do 2 times 14 times 21 for the bottom row, that gives 588. Woo! You could always just use it as a fraction. You could do cos to the minus 1, or you could put it into a decimal. If you put it into a decimal, you're going to get a string of decimals. Here you get 0.40306 and so on. But that's what cos x is going to be. We don't want cos x, we just want to get down to x on its own. We're wanting to get rid of cos. How do we do that? We use inverse cos. Good. If you do that with both sides, on the left-hand side, we'd be left with x. And on the other side, that's where you have cos to the minus 1 of that big decimal. Remember, keep that on your calculator. Don't just write it as 0.4 and do cos to the minus 1 of 0.4. That will be out ever so slightly, which means your answer will be out by even more. So keep that answer super accurate in the calculator. Do shift cos equals, or however it works on your calculator, so you're getting cos to the minus 1 of that huge decimal. And if you put that into the calculator, you end up getting 66.23 degrees. Woo! So that is the size of that angle, 66.23 degrees. And always do a wee check. We're asked for the size of angle X, so we're finishing off by saying X equals, and is the 66.23. Woo! Did you like that? Yeah! Then let's try another one. Here we go. Example 2. Work out the size of the angle marked Y. Okay, go for it, Nella. Talk us through it.
Okay, so it's going to be a cosine rule. We want to find y.
Yeah, you're perfectly right, Nella. So
we write down cos y.
Yeah, you do indeed. So cos Y equals.
And because that's the angle we're wanting where y is, that's going to be angle A in our formula.
It is indeed, yeah. The formula is cos A equals. So that there is going to be angle A. That's the one we're wanting to find.
And that means across from it is small a.
It does, yeah. Well done. Good going, Nella. So that there is going to be small a. And the B and the C, does it matter, Nella?
No, not at all. Just get on with it.
Okay, so you've got cos Y equals B squared plus C squared minus A squared. B and C are the two sides either side of the angle. So we've got 11 and 13. So here I've put 13 squared plus 11 squared. I could also have that back to front, it makes no difference. But I'm taking away A squared, so it's the 4 that I'm taking away. I'm taking away the one across from the angle, so take away the 4 squared. You're dividing that by 2bc, so it's going to be 2 times by the 13 times by the 11. And again, the 11 and the 13 can be back to front if you like. From there, work out the top row. And you end up with 274. And for the bottom row, you end up with 286. Woo! If you work that out in the calculator and put it as a decimal, we're just going to keep quite a few decimal places because it's not our final answer. So you get 0.95804. But that's what cos Y is. We don't want cos Y, we just want Y. How do we get Y? Help us out. Who's going to help us out? Joe, what do? You do cos to the minus 1. So you get Y equals cos to the minus 1 of 0.95844 blah 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 blah. You're perfectly right, Joe. Yeah, very well done. So cos to the minus 1 of our previous answer. Good, and that leaves us just with Y. And if you type that into the calculator, Joe, dare I ask, you get 16.66 degrees. Well done, Joe! Yes, which means angle Y is 16.66 degrees. And again, just a little check. Work out the size of angle Y. We're finishing off with Y equals to 16.66 degrees. Woo! Let's go for another one. Example 3. Calculate the size of angle ACB. So angle ACB is going from A to C to B. So it is this little angle here that I have highlighted. A lot of the time in the exam, in a prelim, in a question, what they will do is they will give you letters to try and confuse you, and they'll mix it up. Here it's the C we're wanting, but our formula is cos A. Your teacher may do this slightly differently. You may rewrite this formula. A lot of the time what I like to do is just ignore the letters that they give you and bring in our letters. So because we've got cos A, this angle here that we are wanting to find, remember this is the one we were wanting, that there then is going to be A. And it means that across from that you would have small a. You do, yeah. Well done, Sophie. So that's going to be small a. The B and the C then are
62 and 99.
Yeah, well done, Sophie. It's the 62 and the 99. Does it matter which one's which?
No.
You're right, it doesn't. So, you can write down cos A equals. I like to just keep it as that, and then you'll see at the end when I just change it and actually answer the question. Some people like to write cos C equals. You can do that if you want as well. It makes no difference. I just sometimes do this to avoid any confusion with any letters. So cos A equals, that there is the A, that's what we want to find. That is small a, so that's the one we're taking away in the formula. And the B and the C will be the 62 and the 99. So we've got the 99 squared at 62 squared, and we're taking away that 103 squared. We're dividing that by 2bc. B and C are the 62 and the 99, so it's going to be 2 times by 99 times 62. Again, it doesn't matter which order you have the 62 and the 99, you can put it back to front if you like. If you work out the top row in the calculator, you get 3036. If you work out the bottom row in the calculator, you get 12,276. Yeah. What do you do next, Tiffany?
Do you put it into your calculator?
You can, yeah. You can put it into the calculator. You get a string of decimals. So I'm just writing down quite a few decimals because that's not the final answer. So 0.24731, blah, 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 blah. That is cos A, but we're wanting to get rid of cos just to leave us with the A. So how do we do that?
Cos to the minus 1.
It is cos to the minus 1, yeah, so A would equal cos to the minus 1 of 0.24731, and so on. Again, keep that decimal even longer on your calculator. Shift cos equals, inverse cos equals, second cos equals. It works differently in all the calculators, but you end up getting 75.68 degrees. Woo! So it means that is the size of this angle. But what I would always do with this is go back to the actual question. We are asked to calculate the size of angle ACB, so don't finish off by saying A equals. What you would do is you would finish off saying, well, we just changed the letters to make it a wee bit easier for us when we're applying the formula. So what you can say then is that ACB is equal to the 75.68. It seems obvious, it seems like common sense, you are getting an answer, but if you're asked for ACB, finish off by saying ACB is this. Don't say something else equals that. Just make sure that you put that down. And that's your answer.
Yay!
Example 4, calculate the size of the angle ABC. So ABC is going from A to B to C, which is this angle here, again the one that I have highlighted. Calissa, what's the matter?
They're trying to confuse us again.
They are trying to confuse you. How are they trying to confuse you, Calissa?
They're putting in different letters. We want cos A in our formula, but the one we want to find is B.
It is indeed, yes. So you could always just ignore that. That's the one we're wanting to find. So that is the one that we're just calling A. Meaning then,
when you cross from that, you got small a.
You do indeed, yes. So that there would be small a. And the B and the C are just going to be the other two angles, and therefore the other two sides, the 5 and the 10. It doesn't matter which one's which, so I'm not even going to bother writing it in. We've got cos A equals, so I normally just start off by writing down cos A equals, and we've got B squared plus C squared, which are the other two sides, the 10 squared plus 5 squared, and the one we're taking away is
the A, which is across from angle A.
Good. So it's going to be the 5 and the 10. 5 squared plus 10 squared, take away the 12 squared, and we're dividing that by 2 times by
the B and the C,
which are the 5 and the 10. Good, so it's 2 times 5 times 10. Excellent! If you work out the top row, boop, 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 you end up with negative 19.
Ooh, negative.
And in the bottom row you get
100, that's easy.
Good. And from there, if you work that out, you end up with negative 0.19 if you put it into a decimal. What you can do here is, we're just wanting to get A, so we need to get rid of the cos. So it's going to be shift cos of that answer. So cos to the minus 1 of the negative 0.19. And if you work that out, you end up with 100.95 degrees. But remember, we're not going to finish off with A equals that, because we're asked to work out the size of angle ABC. So finish off by saying that ABC equals the 100.95 degrees. Also, I know a lot of people, when you're working out cos to the minus 1, you don't like to put in the negative, because you've probably not been doing that since National 4. If you end up missing out the negative, you get 79.05. But what you need to do is you need to think,
this angle here is not going to be 79 because it's bigger than a right angle.
So therefore, you would take that 79.05 away from 180, and either way, you're still going to get 100.95 degrees for your answer. So when it's something like this, either include the negative, so the cos to the negative 1 of the negative, you can go straight to your answer, or do cos to the negative 1 of the positive and take your answer away from 180, because it's not an acute angle, which you can see in the diagram. Hopefully that makes sense. Last one, example 5. Calculate the size of the largest angle in this triangle. Which one is the largest angle? Steve, what do you think? Good, yeah, the largest angle is opposite the longest side. Very well done. Largest angle is always opposite the longest side. The longest side here is the 2, so across from that that there will be our largest angle. Sometimes it's obvious looking at the diagram, sometimes it's not. We are wanting then to work out the size of this angle, but once again they're given the different letters to try and confuse us. We know this is the angle we want to find, so I'm going to ignore that being an F and just call it A so I can apply this formula with cos A equals. If this here is capital A, then across from that is going to be small a. Woo! And if that then is small a, the B and the C would be the 1.2 and the 1.2. Again, I'm not going to bother writing that in. I'm just ignoring the letters that I'm given, making sure the one I want to find is called A, and making sure the side across from that is small a. So from there, I'd say cos A equals, and B squared plus C squared, the B and the C are the 1.2 and the 1.2, and I'm taking away the A squared, and A is 2, so take away 2 squared. Dividing that by 2 times by B and C, so that's going to be the 1.2 times 1.2 when you multiply by 2. And from there, if you work out the top row, you end up with negative 1.12. And if you work out the bottom row on your calculator, 2.88. Good. And from there, if you put that into a decimal, so you divide negative 1.22 by 2.88, you get negative 0.3888. You have a choice. You could either do cos to the negative 1 of the positive 0.3888 and so on. For this though, you would have to then take it away from 180 degrees, or you could just go straight into cos to the negative 1 of that negative answer. If you do that, it is an obtuse angle you will end up with. If you missed out the negative, you would end up with 67.11. That's an acute angle. This is clearly not an acute angle, so you would then take that away from 180. I'll often say as well in the question, work out the size of the obtuse angle, and it'll be clear if you ever get it in the exam. If it is, just include the negative and go straight to the answer, make sure it's obtuse, or ignore the negative and get the acute, and once you've got the acute, take it away from 180. It doesn't matter which way you're doing it. But to finish this off, we're saying A equals the 112.89, but if you look back to the question, you can see that, well, we didn't really have an A to begin with in the question. If I rub out all that, it was this F here. That was the angle we were wanting to find. That was our largest angle, and the name for that angle is Florence! Not quite, no. To name an angle, you would use 3 letters, so you could say it's DFE, or you could just say the largest angle is 112.89 degrees. Yeah! That is some examples with the cosine rule, working out the size of an angle using the cosine rule. As I said in the previous lesson, it was working out the length of a side, and in the lessons before that, it was the sine rule. What I'll do in the next lesson is work out the size of an angle or the length of a side using either the sine rule or the cosine rule, and show you how to know which one to use, because a lot of the time in the exam, you're not told which one to use. It's up to you to work it out. But master this first of all. Make sure you can use the cosine rule to work out the size of an angle in a non-right angled triangle. Yeah. Good luck. See ya. Happy birthday to you. GPG.